So in this video, we're going to pick up the first test for the convergence or divergence of a series. And it's actually not even for convergence. This is only a test for divergence. In fact, you may even see in the important note in red below. This test I'm about to show you will never show you that a series converges. It will only show divergence. So here's the idea. If you have a series, a sub n, right, that series will automatically diverge if the limit of the associated sequence is not 0. So, using math notation, if the limit of your sequence is not 0, then by the nth term test for divergence, this series will automatically diverge, right? And there's a good reason for that, and let me try and sort of show you with not a specific but sort of a conceptual example. Let's say that you had a sequence that was approaching 10. So let's say you had a sequence that was doing something like 1, 5, 8, 9, 9.5, 9.9, 9.99, and so on. If you had a sequence like that, and you decided to add up all of the terms, there's a sense in which, is there any hope that series, that the series 1 plus 5 plus 8 plus 9 plus 9.5 plus and so on, that will add up to something? Is there any hope of that converging to one value? And there's just no, absolutely not. And the reason, just to sort of convince you of it, think about the sequence of partial sums, right? My first one would be 1. My next would be 6. That's 1 plus 5. My next would be 14. That's 6 plus 8. My next one would be 14 plus 9, which is 23. My next one, 23 plus 9.5, that'd be, 32.5. The idea is, at this point, I am now, adding on 10 each time. And it's not exactly 10, but these terms are getting closer and closer to 10. If the terms of my sequence are getting closer and closer to 10, then there is literally no hope of this thing, of the sequence of partial sums converging. And that's why, in order for a series to have a hope of converging, the terms of the sequence have to be tending towards 0. If they are not, there's no hope for you. So I'd like to look at an example of this to give you a chance to try it, right? I want to show that the following series diverges using the nth term test for divergence, and I want us to explain in our own words why the test shows this, right? So let me show you how you use the test. The way you use the nth term test, so first of all, anytime you're using a test, I think you should write the name of the test you're using. So the nth term test for divergence. Right. So the way we do the nth term test for divergence is we do the limit as n approaches infinity of n over n plus 5. This is a simple application of L'Hopital's rule. Turns out it's 1, right? And so the conclusion is, because this limit isn't 1, the series diverges. And while that's the correct answer, that's not actually the explanation that I want. The explanation that I want is why does the test show us this? So I want you to pause the video and think for a minute, write down, it may take a sentence or two, but why does the limit not being 0 mean that this diverges? I know the test says it, but do we understand how the test works and why it's working? So my answer is sort of the idea of the reason that this means the series diverges is that when I'm doing my sequence of partial sums, every time I go to the next sequence of partial sums, I'm adding on a number that's close to 1. It might be 0.999, it might be 1.001, but the important part is, as I am going on and on and on and on and on, I am continuing to add a number that's close to 1. And when you add a number close to 1 infinitely many times, you don't converge. You get closer and closer to infinity. And that's why the nth term test helps us to conclude that our series here diverges. Okay, so I've never titled a slide "Wait, Wait, Wait" before, but I think it's worth it here. And the "Wait, Wait, Wait" is if a sequence's terms approach 0, why doesn't the series just converge? Right? And I realize I should have an apostrophe now. That's just going to bother me. There we go. The nth term test for divergence just showed us that if the terms are not going towards 0, it definitely diverges, right? But if a sequence's terms are getting closer to 0, doesn't that mean that the series would converge? And the answer is no, not always. I mean, it's like we don't know. It depends on the series, right? And the reason is, think about what your reasoning was for why the last one diverged. We said that as we go on towards infinity, we keep adding on things that are close to 1. And when you add up infinitely many things that are close to 1, we don't, it's turning into infinity, right? But what if I had a series that was getting closer and closer to 0? What if I had a series like 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6 plus 1/7 plus 1/8 plus 1/9? This one. And these terms are definitely getting smaller, right? The important thing is, I am adding up infinitely many terms that are getting closer and closer to 0. And we've dealt with this before. We've dealt with infinity times 0 before, because that's what I'm doing. If I'm adding up infinitely many things that are all getting close to 0, I might as well be thinking about that as infinity times 0. But we all know that infinity times 0 is an indeterminate form. I don't know what that is. It might be 0, it might converge. Or it might be infinity, it might diverge. A number of things may happen here. And the reason I chose this particular series is that it's actually a very interesting one. This series, although the terms of the sequence are going to 0, this series diverges. And I can give you a proof of that. I mean, at least a compelling argument, right? If I look at this one term, it's a half. If I look at the next two terms, 1/3 plus 1/4, that will be greater than 1/2. And the reason is, if I have 2/4, that would be 1/2, and I have 1/3 plus 1/4, right? If I look at the next 4 terms, these next 4 terms are bigger than 4/8, which is a half. If I look at the next 16 terms, that'll be, bigger than 16/32, which is a half. And the idea is, if I take the first 1 term, the next 2, the next 4, the next, I think I said 16 here. It should have been the next 8 terms here. I made a mistake in this part of it here. But the idea is, if you keep adding up larger and larger groups of numbers, you'll continue to get a half, and then another half, and another half, and another half. The idea is this series diverges because it adds up to an infinitely large number. I don't know if I made that clear enough here. If you have a question about it, ask me about it in class or shoot me an email. This is a fascinating series that we'll spend some more time with later. But the idea is, if your terms add up to 0, our nth term test is inconclusive. It does not mean that the series converges. Please try to remember that.